Welcome to homework.
This is the answer to Chapter 14, problem number 43 from the Smith Organic Chemistry textbook. And this problem gives us these 10 molecules that I've redrawn here, and it asks us which of these molecules are going to give only one singlet in a proton NMR spectrum. And so for that to be the case, that a molecule gives just one singlet, all of the hydrogens in that molecule need to be equivalent. And so the way to solve this problem is to look at all 10 of these molecules and say, are all of the hydrogens in this molecule equivalent? And if they are, then it'll just give a single singlet, a single singlet. And if they're not, if there are two or more types of hydrogens in the molecule, then we can roll it out. Okay, and so looking at the first molecule here, ethane, so we have two methyl groups really, but they are equivalent. And so this molecule is going to give just a singlet in its NMR spectrum. So then when we look at the next molecule, what we see is that we actually have two types of hydrogens. So this would be one type, and then these two hydrogens are the other type. And so this second molecule is not going to give us just a singlet. So then the third molecule, you might be tempted to say, yes, it is, because these two groups of protons are equivalent. However, if you were to say that, you would be forgetting about the proton that is located on this tertiary carbon. And so there are two different types of protons. So this is not going to give us just a singlet. Okay, sorry, give me one moment here. My computer appears to not be responding. There we go. Okay, and so then looking at the fourth molecule here, we have methyl groups, and then we have other types of protons. So there are three types of protons in this molecule, and so obviously that's not going to give us just a singlet. So that molecule is out. And then looking at the fifth molecule here, so we have two methyl groups, but there's nothing else in the molecule, and they are equivalent. And so that's going to be just the singlet, just what we're looking for. So likewise, in cyclopentane here, molecule number 6, although we have 5 methylene groups, all 5 of them are equivalent. And so that's going to be just a singlet. And so for the 7th molecule here, what we see is these 9 protons are actually different than these 9 protons. And you might not think so at first glance, but what it is the presence of this oxygen right here. So these are in different environments, so they're not the same. So no singlet for this molecule. Although actually, I suppose it would be 2 singlets is what we would see. 2 singlets. So again, we are just looking for 1 singlet. So then moving on, this molecule is similar to the third molecule that we looked at, but this time there are 2 bromines on the middle carbon. So there's no hydrogen on that middle carbon. And so, in fact, all of the protons here are equivalent. And so that's going to give us just a singlet like we're looking for. So then likewise, this alkene here, all of these protons, all 4 of these methyl groups, they're all equivalent. So nothing's going to split anything else. And yeah, so that's going to be just a singlet. And then the same is true of the final molecule here. There are 9 protons on either side, but because they're completely equivalent, they're just going to show up as a single signal. So we'll get one big singlet with an integration of 18 here. Yeah, okay. And so these 6 molecules that I've circled in green are going to be the molecules that show just a singlet in their proton NMR spectra, because all of the hydrogens in these molecules are equivalent. And the 4 with red X's through them have 2 or more types of hydrogens. And so there's going to be splitting and there's going to be multiple signals. And so that's the answer to chapter 14, problem number 43.